So in this video we are going to talk about improving the neural network training using batch normalization. So batch normalization is actually a very popular method in practice because it can do both. It can improve convergence and it can also reduce overfitting. So what is batch normalization? To explain that, remember when we talked about standardizing the input features. Batch normalization is actually a very related concept, so let's briefly review what it means to standardize the input features. So suppose we have a multi-layer neural network as shown here. On the left-hand side to the very left, we have the input features. And usually we normalize or standardize the input features before they go into the neural network. So using the previous normalization or standardization procedures, we normalized the inputs to the network. But what about the inputs to each of the hidden layers? So in addition to normalizing the input features, we can now use batch norm to additionally standardize the values that go into each of these hidden layers. But since it has been a while, you may wonder, how do we actually standardize our input features again? So let's focus on the first feature of the simple neural network here. When we standardized the features in unit 1.6, what we did is we subtracted the mean, so the mean across all the training data points for that feature, and we divided it by the standard deviation. And so this is how we standardize the first feature for training example I. Let's now talk about the first activation value in the hidden layer. So the activation is computed by applying a nonlinear activation function to the net input. We can use then batch norm to normalize or standardize these hidden layer activations. So how does it work? So when we standardize the features, what we did is we standardize the features before they go into the neural network. In a similar way, in batch normalization, what we do is we standardize the net inputs before they go or become the activation. So again, the activation is computed by applying a nonlinear activation function to the net inputs. So the first step of batch normalization is analogous to standardizing the input features, except now for X we have Z, which is the net input. So here we have Z subscript 1, which stands for the first unit in the hidden layer. And then we subtract the average of this first unit across all the different data points. And then similar to standardizing the input features, we also divide by the standard deviation, and we also have a little epsilon term here to avoid a division by 0. So step 2 of batch normalization is the preactivation scaling. Preactivation means here that we apply this computation before we use the nonlinear activation function. So we have two parameters here, gamma and beta. So gamma here is a factor that we multiply with a standardized net input, Z prime. And then we add this beta term here. So beta controls the mean of the preactivation value, where gamma, because it's a factor that we use for multiplication, it scales the spread of the preactivation values. And yeah, beta and gamma are both learnable parameters, just like the weight parameters that are learned during training. By the way, I should note, if gamma is 1, we multiply the standardized net input Z prime with 1, so nothing happens. And if this beta term is 0, we add 0 to this whole expression, and that also means that nothing happens. So in other words, if gamma is 1 and beta is 0, this whole two-step procedure of batch normalization is exactly the same as the input standardization, except that we apply it to the net inputs. Now after applying step 1, the standardization of the net inputs, and step 2, the preactivation scaling, step 3 is to compute the actual activation. So here we apply a nonlinear activation function to these preactivation values. So here we apply this nonlinear activation function to the preactivation values A prime. I know this was a lot of information, so let's actually illustrate how batch normalization works conceptually by comparing it to a network that does not use batch normalization. So suppose we have a network here that does not use batch normalization. So here we have the path from the input features X over the net inputs to the activation value that we would compute in a regular neural network without batch normalization. So here we have the network at the top without batch normalization and with batch normalization at the bottom side by side, to illustrate that the batch normalization is a procedure that happens between computing the net inputs and computing the activation values. So in between we apply step 1, the standardization of the net inputs, and step 2, the preactivation scaling. And yeah, so this is in a nutshell how batch normalization works, and in the next video we will talk about how we can use batch normalization in PyTorch.